Hey everyone and welcome to the channel. Today we're working on a type of pattern welded steel that I personally have never managed to get to successfully work. Cu Mai. I'm hoping to get this welded together into a sand Mai style construction using 3 pieces of pattern welded Damascus steel along with some copper shims in between. If you'd like to see how it was made, stick around to see how we go. So the idea with this one is that I'm chasing a different layer count in the core of the billet to the 2 pieces that will make up the outsides. We'll kick this one off with 20 layers of alternating 15N20 and 1084 high carbon steels. I'll get these ones stacked up in the vise and plop a nice bead of weld down each corner of the billet to hold this one together while we get it forge welded. With our stack all welded together and a work handle attached, it can go into the forge to heat up. With our stack up to forge welding temperature, we'll start nice and slow to get everything stuck together and start increasing the pressure and start moving material a little faster. I do want to stretch this one out to a reasonable length, as I'm wanting to slice this into at least 6 pieces, bring our layer count up over 100. With the first round of weld set, I can leave this one to cool. Now that the billet is cool enough to touch, I can rip off the scale with an angle grinder and get it restacked for the first time, and start the forge welding process again. Following the same process as the last round of welds, I'll start nice and slow and then start increasing the force to really get it moving. With another forge weld done, I'll leave it to cool again and get ready for another stack. With our layer count up to around 100, I want to cut this piece into 6. I'll use 5 for the restack, giving me a piece that has 500 layers that should be big enough to form our outer jacket, and a 100 layer piece for our core, to give us a difference in effect between the 3 pieces. The lower layer piece will be a lot bolder and dramatic, whereas the higher layer count pieces on the outside should give us a much finer and smoother look, with a contrasting piece of copper in between. As a little note, I'm going to forge this higher layer count billet down to the same thickness and height as the low layer piece we left behind, so I'm not grinding off any excess material when it comes to putting these all together. With our steel all forge welded, it's time for the part that concerns me the most, bringing this all together with the copper in between the layers. I'll start off by cutting down some copper sheet to be about the same size as the pieces of steel. I want these to be a pinch undersized. As I'm going to be welding this all the way around the outside with a welder to keep the air out, I don't want the weld contaminated with too much excess copper. And now for one of those why did I do that moments. Whenever cutting anything thin with an angle grinder in the vise, always try and keep the part you're cutting as close to the clamped area as possible. I left mine hanging out too far here, and the excess vibration grabbed my grinder disc and made it explode, which is never a fun thing. Now I can get this one welded up tight, trying to leave no gaps. The reason this is making me uneasy is that the melting temperature of copper is so much lower than steel that if I happen to overheat the billet and squeeze too hard, there's a chance liquid copper could squirt out of the stack and burn anything it touches. I'm really guessing on the temperature here. I know the melting point of copper is somewhere in the bright orange colour range, so if I just stay in the darker oranges and reds, we should be okay. Through a little trial and playing around, I seem to have got my forge to run at a temperature that seems somewhere close to appropriate for the job. Now this does look pretty ugly, but I can't see any copper spewing out anywhere and it all seems to be one solid piece. I'm not going to push my luck today, I simply want to get this down into a flat piece of bar stock so I can cut out the profile I'm chasing. And with our steel made, I'm going to set the profile. The shape we're making today is called a Nakiri. It's a Japanese style knife that's mostly used for slicing and chopping vegetables. It's not really suited to dicing, hence the lack of a pointy tip, but it's a really cool profile, great for blasting through bulk chopping tasks. With a lot of weight removed, this one can go into the kiln to heat up to critical temperature and then plunge into our quenching oil. With it nice and hard, I'll pop this one into temper for 2 rounds of 2 hours, reducing the brittleness and bringing the hardness down to around 60 Rockwell. From here, we're on the home stretch. I think if the steel was going to do anything weird and explode or fall apart, it would have done it by now. So I'll start off by cutting in a center line and then move over to a fresh 36 grit belt to remove the bulk of the material. In my mind, this wouldn't be much different in the grinding to normal steel, but this copper infused steel definitely feels different to me on the grinder. Normally when you grind a knife, the abrasives on the belt wear down, creating more and more friction, and therefore making it get hot to touch quite quickly. I'm not sure if it's because the copper is a great conductor of heat, or the softer material clogs the belts faster, but this definitely seems to heat up faster between passes than normal. Or maybe I'm just crazy and it's exactly the same. It is pretty hot in here today. But anyways, with the bulk of the material removed, I'll move up to a 60 grit belt and bring us down to close to final thickness. I want this knife to be quite thin behind the edge. It ended up being about 1/4 of a millimetre behind the edge, which is on the delicate side, but it should perform quite well. With a few passes on the 120 grit and A100 belts, I can move over to the hand sanding. Starting at 400 grit, I'll bring the surface finish up to 400, and then step it up to 800 to try and shine up that copper a little. Now I'm just treating this the same as any other piece of Damascus. I'll pop it into the acid bath for 3 to 4 cycles at about 10 minutes each. My acid is quite diluted, and I think I'll be due for a fresh batch after this, but I always find it does a better job when it's a bit weaker and you go a bit slower. And here we get a peek at what the finished blade will look like, and it's looking pretty slick. For the handle on this one, I have a really cool piece of dark green stabilised curly mango. I don't see curly woods a huge amount in my travels, but I thought this one would be a good fit for the project. Being a little less busy, it won't take away from the action happening in the blade. So I'll start off by cutting a little slice that will become my bolster and square up the opposite end of the block. Then I'll take my little slice over to the mill and mill in the slot for the tang to poke through. With that fit up pretty nice, I'll cut a mortise into the main block and make sure the hole is deep enough and wide enough to accept our tang. For a little extra accent, I'm going to pop a piece of copper in between the two parts of the handle, along with a couple of G10 shims. With the blade all wrapped up and safe, I'll get some epoxy mixed up with black pigment and get the cavity inside the handle block filled to the top. Then I'll coat all the other surfaces with just a little more to make sure there's no dry spots and bring all the pieces together, pop them into clamps and leave the epoxy to cure for 24 hours. With our epoxy all cured up, we can get to work on the handle. I've been working on the Coke bottle shape handle in my last few videos, and this one's no different. I promise at some stage I'll try a different style. We'll start off by squaring up the block, and then drawing on a bit of a rough profile. Then cut the perimeter shape, and move over to the large contact wheel to cut the contours at the back end of the handle. Then switch over to a slack 240 grip belt to round everything over, so we don't have any sharp spots and it feels nice and smooth in the hand. With the handle all ground in, I'll give it a hand sand up to 1500 grit and move over to the buffer with the pink polishing compound. It's really surprising to me. The waves in this curly mango almost have a 3D effect. It's like looking at a rippled piece of fabric inside the handle. And with the handle all buffed out, I'll whip up a fresh batch of coffee and leave this one to soak until we have some cool contrast. This was a really fun project. It's a nice feeling to overcome something that hasn't worked for you in the past and actually have it turn out pretty cool. This one was staying here with me in the Nomad kitchen. If you'd like to see how it performs, check out some of my upcoming cooking videos, it's sure to make an appearance. Thanks for watching the video everyone. If you liked it, please consider giving the video a like and subscribing to the channel. See you on the next one!